So today, guys, we're going to take another look at scale drawings. We're going to look at a different approach than we did yesterday. Tell me this. We said yesterday that all the measurements, specifically all of the distance measurements, in scale drawings and similar figures are blank. Are what? Jake? They are proportional. Which means we can use all facts about proportions to find those missing measurements. Okay, and there are a ton of different facts that we can use. Now, yesterday we explored one option that we can have. Okay, for example, we had the three examples yesterday. We're talking about two rectangles. So we had rectangle 1 and rectangle 2. We had triangle 1 and triangle 2. Or we had the one with the lady in the tree. Okay, and for all three of those, we set up a proportion. They look like this: a fraction equal to a fraction. Now, on the one side, we had triangle 1, rectangle 1, or the lady. Call that figure 1. On the other side, we had triangle 2, rectangle 2, or the tree. Let's call that figure 2. Now, on all of those figures, there were two measurements. Okay? On the rectangle, we had length and width. On the triangle, we had base and height. With the lady in the tree, we had the height and their shadows. Well, let's stick with length and width. Now, it's not always going to be length and width. Okay? We saw, like we said, the height of the tree and the shadow of the tree. We had the base of the triangle, the height of the triangle. But let's just use length and width to make it simple. Now, this was our first option. We're going to learn about a second option that we can use today. But first, let's put option 1 into action. So, who likes to paint? Okay, Katie, read number 1 for us, please.
In our class, Alyssa,
Hold on, Katie. Go ahead.
In our class, Alyssa made a rectangular painting that was 8 inches long and 6 inches wide. Mr. Miller wants her to make it bigger. If Mr. Miller says the painting has to be 20 inches long, how wide should it be?
All right, so here's the painting that Alyssa made. It's a beautiful painting. And this painting is 8 inches long, and it is 6 inches wide. But Mr. Miller says, you know what, Alyssa, that painting is really nice. I'd like it to be bigger, though. Here's how big I'd like you to make that painting. I'd like this painting to have a length of 20 inches. But Alyssa needs to figure out what the width is going to be. So they're giving us two different shapes. Okay, the original painting and the expanded painting, the enlarged painting. They're giving us the length and width of each of those paintings. So we're going to set up a proportion. Now, on one side of the proportion, I'm going to have the original, the first one that Alyssa did, and then on the second one, I'll have the enlarged. Now, what measurements do I have for both of those paintings?
Inches.
Okay, they're both measured, everything's measured in inches, but what are those inches measuring? Length and width. So, that's what we're going to use. Now, do you want to put length on top or width on top? No wrong answer. Okay, the catch is we have to put length on top for both of them. And then we'll put width in the bottom for both of them. Now, on that original drawing, what is the length on the original drawing? 8 inches. What is the width on that original drawing? 6 inches. Don't forget the inches. What is the length on the big drawing? 20 inches. What is the width on the big drawing? X. Okay? I'm going to stick with W. You're right, it's our variable. It's our unknown. You can use X, but I'm going to stick with W for width. Okay, so I've got my proportion set up now. How do we solve proportions?
Cross multiply.
We cross multiply. So when we cross multiply, 8 times W will be 8W, and 6 times 20 will be 120. Now I want to get that W all by itself. What do we do?
Divide 8 on both sides.
Say that again?
Divide 8 on both sides. From both sides.
Okay, divide both sides
Oh.
by 8. Okay, remember that division is not commutative. If we say divide 8 by both sides, we're putting 8 on top. We want to divide both sides by 8 because we want 8 to be on the bottom. Now on the left side, those 8s are going to cancel. W is all by itself. And what's W equal to? 15. Now we can take that 15 all the way back to the original and check it out. Okay, do 8 over 6 and see if that's equal to 20 over 15. So this half of the room by the windows, I want you guys to do 8 over 6. This half of the room by the door, I want you to do 20 over 15. Okay, what'd you guys get over here?
1.3 repeating.
1.3 repeating. How about over by the door? What did you guys get?
1.3 repeating.
Good. So our solution checks out. So our complete sentence answer, what can our complete sentence answer be? Give me a complete sentence answer. To Leah. Say that again nice and loud, please. It should be 15 inches long. 15 inches long? Wide. Good. Okay, remember, a single tick mark means feet. The double tick mark means inches. Now ask yourself, does that seem reasonable? Okay, 15 inches is about this long. Does it seem reasonable for Alyssa to make a painting that's this wide? Sure. Okay, sure. Now remember, reasonable won't guarantee correct, but it'll help us weed out the crazy answers. Yeah?
Didn't we put the painting should be?
We can put the painting should be, okay? It should be is going to get the point across. All right, questions about number 1? No questions? Okay, so let's talk about a second option here. Now we said that we can use all facts about proportions to find those missing measurements. What other equation do we have that goes with proportional relationships? Y equals kx. Okay? So that's a fact about proportions. We get to use it. Now what's important about story problems and these types of equations? What do we have to do? We have to define these variables. A formula is no good if you don't know what the variables represent. So we have to say what x, y, and k all represent. So if we're talking about a scale drawing, x is going to be the original or the actual distance. Y is going to be the scale distance. Okay, so think about a map. Okay, a map is a scaled down version of an actual place. The actual distance in the real world would be x. The distance on the map, okay, that tiny little couple of inches distance on a map, that's going to be your y. Okay, so the actual distance is in the real Earth. Y, the scale distance, is on that actual picture, holding up a ruler to that picture. So then we got this k again. Now what does k represent? Not just in this story, what does k always represent? Okay, y per x. The unit rate. The constant of proportionality. All three of those. Now, in this particular case, that unit rate, that constant of proportionality, y per x, is scale distance per actual distance. We call that the scale factor. And the scale factor gets a fancy definition. Okay, the scale factor is the constant of proportionality between dimensions of an object and the corresponding measurements corresponding dimensions on the scale drawing. The scale factor is the constant of proportionality between the dimensions of an actual object, the real deal, and the corresponding dimensions on the scale drawing. What's that word corresponding mean again? What does corresponding mean to us? Alike, similar, specifically, guys, they're in the same place. Okay, it's the same measurements in the same place. So if we're looking at a map of Pennsylvania, the distance on that map between Pittsburgh and Philadelphia would be proportional to the actual distance in the real world between Pittsburgh and Philadelphia. Now, we're going to use this to answer question number 2. So, who really, really, really likes social studies class? Cammie? Read number 2 first, please.
On a map in Mr. Custodian's class, we measure the distance between
Uh-oh. Sorry. Egypt. Well, that's not how it's pronounced, but it's a city in Egypt.
Cairo,
Cairo.
and Marsa.
Perfect.
And 1 3/4 inches of the scale is 1 inch is equal to 200 miles. How far apart are Cairo and Marsa in real life?
Okay, good. Now, guys, on this one, they're giving us 2 different things. So we have actual Marsa Alam and actual Cairo, and then we have them on the map. Okay, but the problem is we only have one distance. Instead of having length and width, we only have the distance between those 2 cities. So we can't really set up a proportion like we did on number 1. But what we can do is make a y equals kx equation. But in order to do that, I need to define x, I need to define y, and I need to find a k. Now we said x is going to be the actual distance. So that's miles. It's the actual distance in real Egypt. Y is going to be on the map, which is in inches. Then I need to find k. Well, k is the scale factor. How did we find k last unit? How did we calculate k, Jake? Very good. Y divided by x. Well, guys, right here, 1 inch equals 200 miles. This is our scale factor. This is our k. So our k is going to be equal to the y, the map, inches, which is 1 inch, over, in place of x, the actual distance, which is 200 miles. So they're giving us the scale factor. They're telling us that the scale factor is 1/200. So we can make the equation y equals 1/200 times x. So this is the equation that we would use to answer questions about this story. I can find distances on the map. I can find distances in actual Egypt. But what they've given us is 1 3/4 inches. This, guys, is a value of y. They're telling us that y equals 1 3/4 inches. Now, 1 3/4 inches is great for a final answer, but I'm going to have to use that 1 3/4. So what should I do with 1 3/4? Okay, hold on. Before any of that, I need to do something with that number. Katie, I either need to turn it into an improper fraction or a decimal. I'm going to go with the improper fraction. What would that improper fraction be? Say again? Good. 7/4 inches. Now, this is what Shane was just about to get at. I have a value of y. Let's take it and put it in place of y. So we have 7/4 equals 1/200 times x. And I need to solve for x. Well, x is getting multiplied by 1/200. What can I do to get x by itself? Divide both sides by 1/200. How do you divide by a fraction? Multiply by the reciprocal. So that's what we'll do. Sloppy there. Better. Now, how do you multiply fractions? Straight across. So 200 times 7 is 1,400. 1 times 4 is 4. 1 times 200 is 200. 200 times 1 is 200. What does 200 over 200 equal? Shout, yeah, 1. Okay? Well, what does 1x equal? Just x. So I have 1x is 1,400 over 4. And this is where the calculators come in. 1,400 divided by 4. What do we get? What'd you get, Annabelle? 350. Now we can sub that all the way back into the original. We can do 1/200 times 350. And if we do that, we should get 1 3/4. So our solution checks out. We can write our complete sentence. Now remember, Cairo and Marsa Alam are two cities in Egypt. The question says, how far apart are the two cities in real life? Well, someone give me a complete sentence answer, please. Talia? Cairo and Marsa Alam are 350 miles apart. Okay, now remember, ask yourself, does that seem reasonable? Now, it's tough to wrap our heads around. 350 miles sounds like an insane distance. But keep in mind, we're talking about two cities in a country. Okay, Pennsylvania, or excuse me, in Pennsylvania, Pittsburgh and Philadelphia are, I think, about, excuse me, about 200 miles apart. So does it seem reasonable that two cities in the same country could be 350 miles apart? Sure. It's perfectly reasonable. So, we can bring back the old y equals kx. Okay? Y is going to be the distance on the map, the scale distance. X is going to be the actual distance. And k is going to be that scale factor, y over x. So we set up a y equals kx equation. We'll sub a value in for either x or y, depending on what they give us, and solve for the one we don't have. Just make sure to include units in your complete sentence final answer.